Myself, Vasundhara Shukla, Assistant Professor in Electrical Electronics Department of Oriental College of Technology, Bhopal. In last lecture, we have discussed rectifier. Today, we discuss the introduction of BJT. The full form of BJT is bipolar junction transistor. Junction transistor is generally called as bipolar junction transistor. The BJT transistor have three terminals: emitter, base, and collector. Emitter is to inject charge carrier into the base. Emitter has to supply large number of carrier and it is heavily doped. Base is very thin region and it is lightly doped and it pass all charge carrier onto the collector. Collector is to collect the charge carrier. Bipolar junction transistor name itself indicate that it has two junctions between p-type and n-type semiconductor. The BJT transistor are classified in n-type, NPN and PNP transistor depending on the construction. The transistor is a three-layer semiconductor device consists of either 2n and 1 p-type layer or 2p and 1 n-type layer of material. The former is called NPN transistor while latter is called PNP transistor. The symbol of NPN transistor and PNP transistor is shown in figure. DC biasing is necessary to establish the proper region of operation for AC amplification. BJT transistor are current control device. The emitter layer is heavily doped, base is lightly doped, and collector is also lightly doped. The term bipolar reflects the fact that holes and electron participate in the injection process into a positively polarized material. If only one carrier is used, electron or hole, it is called as unipolar device. Bipolar junction transistor can operate three regions. They are cutoff region, active region, and saturation region. The transistor is off state, that is, current flowing through the transistor is zero. When transistor is in active region, it acts as amplifier. In saturation region, transistor is fully on state and work as closed switch. The BJT transistor have low input impedance and it cause to flow large current through the transistor. Generally, there are three different configuration of transistor: common base, common emitter, and common collector. The circuit diagram of common base, common emitter, and common collector is shown in figure. Now we discuss transistor as an amplifier. A transistor acts as amplifier by raising the strength of weak signal. The DC bias voltage is applied to the emitter base junction. It make remain in forward bias condition. The low resistance in input circuit lets any small change in input signal to result in appreciable change in output. The basic amplifying action was produced by transferring a current low to high resistance circuit. Transistor is a combination of transfer resistor, that is transistor. Now we prove the transistor as an amplifier by mathematically. For example, let there be a change of zero point 0.1 volt in the input voltage being applied, which further produce a change of 1 milliampere in the emitter current. This emitter current will produce change in collector current, which would be 1 milliampere. A load resistance of 5 kilo ohm is given. It produces voltage 5 volt. Here we observe that change of zero point 0.1 volt in the input give change of 5 volt in the output, which means the voltage level of signal is amplified. Now again, in PNP common base configuration, input voltage is given 200 millivolt, input resistance is 20 ohm, load resistance is 5 kilo ohm. Again, we have proof transistor act as amplifier. Here, first we find input current. Input current equals to input voltage divided by input resistance. In question, we have given input voltage 200 millivolt divided by input resistance 20 ohm. We get input current 10 milliampere. This is a emitter current. By using current amplification factor, it is ratio of output current to input current. Alpha equals to IC upon IE. Here we find IC equals to alpha IE. If we assume alpha equals to 1, then IC equals to IE. We have already find IE 10 milliampere, so IC also 10 milliampere. Now we find output voltage. Output voltage equals to IC into RL. IC 10 milliampere and load resistance is given 5 kilo ohm. We get 50 volt. Again, we see that when we apply 200 millivolt in output, we get 50 volt. So transistor amplify the signal. In next lecture, we discuss common base configuration. Thank you.